Hello students, welcome to the course Industrial Automation. The first unit is about the industrial automation in production system. Okay, so as we all know that in all the manufacturing sectors, the production systems plays a very important role, and it is very mandatory to introduce the automation in case of production system. Okay, so all the manufacturing sectors are introducing the industrial automation. Okay, so in this lecture we are going to explore what is industrial automation, what is the need for industrial automation, what are the elements of industrial automation, evolution of industrial automation. Then we are going to explore what are the various levels of automation and also advantages of industrial automation and applications of industrial automation. So coming to introduction to automation systems. So first let us define what is an automation. It is a technology by which the process or procedure is accomplished without human assistance. Okay, so the things has to be done without human intervention. Okay, how this can be implemented? This can be implemented using a program of instruction combined with a control system that executes the instruction. Okay, so to automate a process, the most important thing to be noted is the power. The power is required not only to drive the process itself, but also to operate the program and control system. Okay, although automation is widely used in variety of areas, the main thing to be noted is a manufacturing industries. Okay, and this word manufacturing was first coined by a engineering manager at Ford Motor Company in the year 1946 that described a variety of automatic transfer devices and feed mechanisms that has been installed in the Ford production plant. And it is ironic that nearly all the modern plants applications of automation are controlled by the computer technologies which was not available in the year 1946. Next is the elements of automated system. So in the previous slide we have discussed about what is automation. Okay, so in that the process is accomplished without human intervention, and this can be done by means of a program. Okay, program combined with a control system. Okay, and for this a control a power is very important. Okay, so with this basic concept, the most important element in the automated system, it is going to consist of three basic elements. One is power to accomplish the process and operate the system, and second is a program of instructions to direct the process, and the last is a control system to actuate the instructions. Okay, all these three are the major elements of the automation system. Okay, and they are present in the three basic types of automated manufacturing. Okay, there are three types of automated the automation in the manufacturing systems. One is a fixed automation, second is a programmable automation, and the last one is a flexible automation. So there are three types of automation: fixed, programmable, and flexible. Okay, so here it is showing the relationship between the production quantity and product variety. Okay, so x-axis represents the production quantity and y-axis represents the product variety. Okay, so here it is very clear that fixed automation can go for a mass production. Okay, because we are not at all going to change the program, so the program is going to run off its own, so you can have a the maximum production quantity when you go for a fixed automation. Okay, and coming to the next one is called as a programmable automation. Programmable automation is each and every time we have to change for a particular set of product, we have to change the program. Okay, so that cannot go for a mass production where you can execute the batch production, that is called as a programmable automation. And flexible automation, it can have a maximum production as well as you can able to change the program. Okay, so it is a combination of both the fixed and programmable. Okay, that's why you can see that it is represented, the production quantity is represented mid of programmable automation and fixed automation. So first one is the power to accomplish the automated process. So there are three elements of automated process. First is the power. Okay, so what is this power? The automated system is used to operate some process where power is required to drive the process as well as the control. Okay, so the principal source of power is nothing but the electricity. Okay, so electric power has many advantage in the automated as well as a non-automated process. Okay, so and we are aware that it is widely available at a moderate cost, and it is very important part of the industrial infrastructure. Okay, and even in the industrial infrastructure, you can readily convert the electrical power can be readily converted into a alternative energy forms like a mechanical, thermal, light, acoustic, hydraulic, and pneumatic. Okay, so the most important thing is electric power is used to accomplish the functions. It is also used to accomplish the functions like signal transmission, information processing, and data storage and communication. Okay, so this energy can be stored in in a long life batteries for use in location where external source of power supply is not conveniently available. So coming the process called casting, which is going to the power form is the thermal. Okay, so here melting the metal before pouring into a mold cavity where solidification occurs, that is called casting. Okay, and next is the EDM, electric discharge machining. Okay, it is power form is electrical. The metal remover is accomplished by series of discrete electrical discharges between electrode and workpiece. The electrical discharges causes a very high localized temperature that melt the metal. Okay, so these are some of the processes involved in the manufacturing industries. Next is a forging. Forging, the power form is a mechanical. The metal work part is deformed by opposing dies. Work parts are often heated in advance of deformation, thus thermal power is also required. Next is a heat treating, that is thermal. Metallic work unit is heated to temperature below melting point to effect the microstructural changes. And next is the injection molding, thermal and mechanical. The heat is used to raise the temperature of polymer to highly plastic consistency, and mechanical force is used to inject the polymer melt into a mold cavity. And next is a laser beam cutting, light and thermal and mechanical. A highly coherent light beam is used to cut the material by vaporization and melting. A cutting of metal is accomplished by relative motion between tool and workpiece. Next is sheet metal punching and blanking, which is coming under the mechanical power. The mechanical power is used to shear the metal sheets and plates. And next is a welding, where thermal. It may be sometimes may be mechanical. Most welding processes use heat to cause a fusion and coalescence of two or more metal parts at their contacting surface. Some welding processes apply mechanical pressure. So next element of automated system is program of instructions. Okay, so the action performed by the automated process, that is a sequence of operation which is defined by a program of instruction. Okay, so whether the manufacturing operations involve low, medium or high production, each part or product requires one or more processing steps that are unique to that product or parts. Okay, so these processing steps are performed during a work cycle. Okay, the new part is completed at the end of each work cycle. For example, plastic injection molding operation, it may produce multiple parts each cycle using a multiple cavity mold. Okay, and similarly, a particular processing steps for work cycle are specified in a work cycle program that is called as a programs in a numerical control. Okay, so you know very well NC, that is CNC machine, where you use a computer to execute the numerical control. So you are going to perform the particular processing step for a work cycle in a specified work cycle program. Okay, so that is called as a NC. So other process control application uses different names for the type of programs. Okay, so this is a second step of automation. So coming to the last element of automated system, which is a control system, which is familiar to all of us. A control system of a automated system, it executes a program of instruction. Okay, so this control system, it causes a power to accomplish in its defined function, which is used to perform some manufacturing operation. Okay, so you define that as a closed loop control system. Okay, so closed loop control system is nothing but you will feed the input parameter and you will get the output variable. Okay, so the main thing is a process. Okay, so process is the main thing, and for the process you will get a sensor value. Okay, so what parameter you are going to control. Okay, so that is measured using a sensor, and that value is given to the controller. So the controller is going to compare the sensor output with the input parameter, and accordingly it is going to send the signal to the process via the actuator. Okay, so this is called as a closed loop control system. Okay, which is a main part of the automation. So coming to the automation and controls technologies in the production system. So this represents the levels of automation in the production system. So we have a factory level and another one is a enterprise level. Okay, so factory level where you will have only the workers, and the enterprise level we have the top officials. Okay, so you can see here is the manufacturing operations, manufacturing systems, automation and control technology, material handling, all are done in the, and also quality control. Okay, so all are done in the factory level. Okay, so enterprise level they will fully perform the manufacturing support system. Okay, how the manufacturing support system is done by having a information about the manufacturing system, and also get the information about the quality control and what is the information about the operating system. Okay, so manufacturing operations. Okay, all these data are collected at the enterprise level in order to execute the operation at the factory level. Okay, so in this way the automation and control technologies in the production system. Okay, so this particular picture is given in the cover page of the uh, textbook named Automation Technologies by Michael P. Grover, so which is a famous popular block diagram about the automation and control technologies in the production system. So next is the evolution of automation system. So that is in history of industrial automation. Okay, so first is the evolution of industrial automation. Okay, so first is the evolution of the computer. Okay, so we know very well the computers begin from a large size device consisting of lot of vacuum tubes and lot of other components, which is very difficult system to work and has limited in its application. So nowadays we are very familiar that latest computers are smaller in size and great speed in order to perform the multiple applications at the time. Okay, so you can see the diagram representing how the evolution of the computer from a bigger size to a smaller size, and the thing to be noted here is a bigger size computer is very difficult, and also the memory capacity is lesser in those days. And the coming to the modern or latest computer, the memory capacity is very vast. Okay, so that is noted, that has to be noted in a first. So next is in automation is a human control. Okay, so industries were most convenient controlled using a manpower. Okay, so in those days, okay, so very simple industries, the process was simple. Okay, so we can use a manpower. Okay, so with time and development of invention of new instruments began, the process started being complex. Okay, so when it is simple, manpower is sufficient. Okay, so human control, these requirement increased the need to replace a certain simple human control conditions with mechanical, pneumatic and electrical devices. Example, we go for a relay. Okay, so the introduction of relay in have evolved the next type of control called electrical control. Okay, so the development of electrical devices like relay made simple operation, like simply you are going to on and off, to be done by these devices than humans in the field. Okay, so this was a huge step towards the automation. Okay, so this step of relay-based control and simple computer operations started making process control much easier, but biggest drawback was massive wiring of relay system. Okay, so that is and also it is very difficult to troubleshoot. Okay, that is very difficult. Okay. Combination of electrical control. Moving to the next type of control called electronic control. With the development of microprocessor and microcontrollers, the relay logics were implemented using a gauge on a simple IC chips. This reduces the wired system largely, okay, and also most efficiently control. And there is a drawback in this also. Okay, the drawback is this microprocessor and microcontroller are difficult to work due to high temperature in the process industries. It is very difficult to withstand, and also we need a required skilled people to do this job. Okay, and the devices were application specifically programmed, and upgradation of process meant replacing the entire kit. Okay, so that is also a challenging if you go for a electronic control, though troubleshooting and it is reducing the wired size also, but the main drawback is it cannot withstand the high temperature as it is used in the industries. Okay, so that is a drawback of a electronic control. So in continuation of electronic control, the next one is a PLC and DCS based control. Okay, so the above issue, that is withstanding high temperature. Okay, so that can be overcome by means of a device called PLC. This device was first proposed by Richard Morley in the year 1960. Okay, so the answer to the most of the industrial requirement was met. Okay, so this is designed as a rugged device with proper production, thus making it suitable for various kind of industries, and also it is very simple and does not require any skilled programmers. Okay, so that is a very important point to be noted here. When upgrading had to be done, addition of input and output were also easily, only IO module has to be added to the existing control system. Okay, so this advantage have made the PLC the best solution for a complete industrial automation, and also over a period more complex control operation lead to a DCS also become prominent in a process control. So with this evolution concept, it is very clear the advantages of automation. So by means of automation, one can achieve higher production rate and increased productivity. Next is more efficient use of materials, and by means of that, better product quality can be ensured, improved safety, shorter work weeks for labor, and reduced factory lead times. Higher output and increased productivity have been the two of the biggest reason in justifying the use of automation. Okay, so despite the claim of high quality from good workmanship by human, automated systems typically perform a manufacturing process with less variability than human workers, resulting in a greater control and consistency of product quality. Also, increased process control makes more efficient use of raw materials, resulting in less scrap. Okay, so that is these are the advantages of automation. So coming to the applications of automation, so mainly manufacturing companies in a virtually every industries are achieving a rapid increase in the productivity by taking advantage of automation technology. Okay, so when one thinks of automation, robots come to your mind. Okay, so the automotive industries are was the earlier adopter of robotics, using these automated machines for main purposes material handling, processing operation, assembly and inspection. Okay, and also industries like electronic industries also. Okay, so with its need for mass customization of electronic goods, miniaturization of electronic goods and the internal components, and re-standardization of semiconductor industries. Okay, so robotics will continue to expand in even the food and beverage industries that will perform some of the tasks like packaging, palletizing and filling, as well as it also finds application in aerospace, appliances and non-manufacturing markets also. So coming to the levels of automation, there are 5 levels of automation. So if you take the automation hierarchy, the lowest level is a device level, okay, and the next level is a machine level, and followed by a system level, okay. So here next is a plant level, another one is a enterprise level, okay. So this is the hierarchy of the uh, automation, okay. So 5 levels of automation in the manufacturing sectors. First is a lowest level of hierarchy is a device level, okay. So device level means the field instruments like sensors, actuators and other hardware elements comes into the picture. And next is the machine level, where you are going to combine all the devices into a machine, okay. Individual machines, you call that as a machine level, okay. And next is the cell or system level, where manufacturing system group of machines, you call that as an individual machine, you call that as a machine level. A group of machine, you call that as a cell or system level, okay. And one which is going to ensure the production system, that is plant level, okay. Plant level is nothing but converting a raw material into a finished product, okay. That is called plant level. And finally we will have end up with the enterprise level, which is nothing but the corporate information systems, okay. So these are the 5 levels of automation in the industries, okay. So finally I will consolidate what are the things we discussed in this lecture. So first we started with the definition of automation, what are the elements of automation, then moving to the levels of automation, okay. So we have a different types of automation, then advantages, applications of automation, and finally the levels of automation. Thank you.